In this video, we are going to discuss about radius of curvature. And there are two different aspects of radius of curvature. One is with physics, other is with maths. Generally, we can easily relate radius of curvature in physics, but it is slightly difficult to relate the radius of curvature in maths. Although your maths teacher can easily give you some idea of that particular part. So here I am going to give you both the solutions. First from the physics aspect, second from maths aspect. Okay, so as you know, radius of curvature is the radius of an imaginary circle. Okay, it is radius of an imaginary circle which perfectly fits at a particular point of a curved path. I'll show you. Let's say a particle is moving at this point with a speed v, and this is a small length of the path, okay, somewhere here. So this small length can be considered to be part of a circle which perfectly fits here, and radius of curvature is the radius of that circle. In mechanics, we can easily say that whenever a particle is moving on a circular path, we need a centripetal acceleration. Okay, this particle may be having two accelerations. One may be tangential acceleration, and the second is definitely centripetal acceleration, because whenever a particle is moving on a curved path, centripetal acceleration is always there. Okay, so you can just write centripetal acceleration is equal to v square divided by radius of curvature, which you have learnt in circular motion. So from physics point of view, you can easily write radius of curvature is equal to v square divided by a perpendicular. Now we are going to discuss the same thing with mathematical point of view. Okay, so I am assuming that there are 2 points. One point is A and the other point is B. Okay, slope at A is theta, tan theta, and slope at B is tan theta plus d theta. I am assuming two perpendicular coordinates x and y here. So this is x-axis and this is y-axis. So if you draw a tangent here, and if you extend it, tan theta is the angle made by this tangent with the x-axis. This angle is theta. You can extend it. This is your tangent at point A. Okay, so now I am going to write this small length dl in two different ways. dl means A to B length. A to B length is r d theta. Why it is r d theta? Because slope at A is tan theta and slope at B is tan theta plus d theta. So the angle between two tangents at A and B is d theta. You know the angle between two lines is same as angle between their perpendiculars. So if angle between two tangents is d theta, then angle between two normals will also be d theta. So this angle is also d theta. If this angle is d theta, then this length AB is r d theta, which is also equal to square root of dx square plus dy square. Okay, so now I want to calculate ROC, which is R here. So I'm dividing both sides by dx. So this will become R into d theta divided by dx is equal to square root of 1 plus y prime square. Y prime is dy by dx, right? So now you want to calculate d theta by dx. You know slope at A is tan theta and slope at B is tan theta plus d theta. Position of A is x. This is x, comma y, and this is x plus dx, comma y plus dy. This is your point B. Okay, so you can also write that slope is dy by dx and rate of change of slope is second order derivative of dy by dx. Okay, so I'm writing here, you know, tan theta is dy by dx, and if you differentiate both sides you'll get sec square theta d theta divided by dx is equal to second order derivative of y with respect to x. I wanted to calculate d theta by dx, so I'm done because I got d theta by dx. This is 1 plus y prime square, and you have a sec square theta in denominator, which will become yeah. So d theta by dx is equal to d2y by dx square divided by sec square theta. Sec square theta will go in numerator, and sec square theta is 1 plus tan square theta, and tan theta is dy by dx. So this is another 1 plus y prime square. Okay, so this is your famous equation of radius of curvature, 1 plus y prime square to the power 3 by 2 divided by y double prime. Sometimes you need radius of curvature for elliptical path, because if you want to apply Newton's law for a planet which is revolving on elliptical path, and if you apply Newton's law, then you need to know the radius of curvature at this point, or any general point. So if the equation of ellipse is x square upon a square plus y square divided by b square is equal to 1, then you should check the radius of curvature at this point is b square divided by a, and radius of curvature at this point is a square divided by b, and you can use it directly. So you should definitely try, and let me know if you have any issue. I'll explain you. Okay, so in many cases you can calculate radius of curvature by using this formula. So this is uh, you can say mixing of mathematical concept with a physics concept. So in terms of physics, uh, it is something which is a necessity, or you can say if something is moving on a curved path, that a small part is can be considered to be a part of circle to analyze the dynamics of motion. But if it is mathematics, it is just a radius of curvature. That is mathematical aspects of this same thing. Okay, now I am giving you one more interesting problem, pedagogical machine, because these types of machines are very useful in learning mechanics, fundamental concepts of mechanics. So there is a large block, heavy block placed on smooth surface. There is no friction. Okay, then there is a pulley and there is a block. Basically, there are two blocks. The pulley is connecting these two blocks, and there is no friction anywhere. All the surfaces are smooth. Mass of this block is m, mass of this block is alpha m, mass of this block is beta m. Okay, all the surfaces are smooth and we are applying a force F here, which is a constant force. So you have to solve two different parts. First, calculate F so that capital M remains stationary with respect to beta m. B. If F is equal to 0, calculate acceleration of all the blocks. Okay, and I think you should try this question in by many ways. First, by making free body diagram of each and every block. Second, by using system approach, and third, by pseudo force. So you should try at least thrice, and every time you should get the same answer. Okay, I'll give the solution of this problem within 2-3 days, and I hope you will enjoy this problem. We'll meet again. Good luck.